Hello class, and welcome to lesson 3.3. Today we're going to learn about our third method of solving linear systems by elimination. Before we hit the third method, let's quickly do the warm-up and review the first and second method of solving. So let's take a look at this warm-up. Number 1, solve this linear system algebraically. Okay, so that's the only method we know so far about algebraically is the substitution method, so that's currently method number 2. That we just learned last class, and then check by graphing. So that's another method, and that's your method 1 that we learned the first lesson through this unit. All right, so here's our linear system, ladies and gentlemen. We've got 2 equations, so I'm going to rewrite them over here. So I got 2x minus 3y equals 6, and that's equation 1. And my second equation is y equals 2x plus 2. That's equation 2. Now notice that my second equation is already rearranged. So I'm just going to say sub 2 into 1. So wherever I see a y in the first one, I'm going to replace it with, so wherever I see a y in the first one, I'm going to replace it with 2x plus 2. So it's going to look like this. I'm going to go 2x minus 3. Give me a second to put a different color in. 2x plus 2 equals 6. So there's the substitution part, folks. And notice now when you've substituted in that there's no y variable, so we're going to use our simplification of a linear equation to get x by itself. So it's going to be 2x minus 6x minus 6 equals 6. Then we're going to realize how many x's do we have on the left. We've got negative 4x. I'm going to bring that negative 6 over, and I'm going to add it to the other side. So I've got negative 4x equals 12. To get x by itself, you divide both by what currently x is being multiplied by, which is negative 4. Simplify through, and you're going to get x equals negative 3. Sub x equals negative 3 into equation 2, because that's the easier one. Y equals 2 times negative 3 plus 2. Y equals negative 6 plus 2. So y equals negative 4. So we've got our x, we've got our y. Don't forget your conclusion statement here. Therefore, solution xy equals negative 3 over negative 4. Just a side note, folks, if I say to solve algebraically and then check, I would just want you to check using left side, right side checks. However, I did ask you to check by graphing, so by using another method. Okay, so most times you're just going to set up, if I ask you for the check, the left side, right side. So let's just rewrite our equations. We've got equation 1, which is 2x minus 3y equals 6. It's equation 1. And because the coefficients in front of x and y go in evenly into the constant, I'm going to use x and y intercepts. So x-intercept, I'm going to let y equal 0. So I'm going to rewrite this wherever I see a y, I'm going to put a 0. So it's going to be 2x minus 3 times 0 equals 6. So we got 2x equals 6. To get x by itself, x equals 3. Sorry, hopefully that didn't stop. Okay, hopefully we're still going here. I had a computer default there. All right, let's just double check to make sure we're still recording, guys. Yep, we're good. Okay, hopefully that works. Okay, so we've got x equals 3 as our x-intercept. Sorry, now I need to close this stuff. Exit that. Okay. Now it's not responding. Sorry. How do I do this? Let me pause it and see if that'll help. Okay, guys? That's fine. Okay, here we go. All right, so apologize for that, guys. So here we go. X-intercept, or if you want to know, that's the ordered pair 3 and 0. Okay, so I plot that point. Okay, now let's go find the y-intercept. The y-intercept is when x equals 0. So I rewrite this wherever I see an x, I put a 0. Okay, so I'm going to be left with negative 3y equals 6. To get y by itself, divide by both sides by negative 3. So y equals negative 2. So that's the ordered pair 0, negative 2, if you're not sure. So plot that on the y-axis. Okay. And let's join a line for that. Here we go. Okay, I think that looks pretty good there. Okay. Make sure you have arrows on both ends, guys. Okay. And make sure to label the equation, equation 1. All right. That looks good. Okay. Now we're going to do the second equation, which I'm just going to put down below here. So equation 2 is already in the form y equals mx plus b. It's y equals 2x plus 2. Equation 2. And how about I change the color and go blue? So let me just make that in blue, just so you can see it a bit better. Okay, and I'll put blue on the graph if you want me to. So looking at y equals mx plus b, we know our y-intercept is 2. Our slope equals 2 over 1. So I'm going to take my equation. I'm going to graph this equation, I'm going to start at b on 2. And then from there, I'm going to go up 2 over 1, up 2 over 1, and get a pattern. Draw this line. Okay. Okay, so here we go. Properties. Get the arrows. I said I was going to make it blue for you. Okay. So we've graphed both. I got to remember to label this equation too, so I know I've got both of them, which one's which. Then on your graph, folks, you look at your point of intersection, and you write P of I, and I have -3, -4. Therefore, solution xy equals -3, -4. Double check, is that consistent with what we already have? Absolutely. So that proves that it is correct, because they both are the same. If you had a different solution here, ladies and gentlemen, you should go back and find out where you made an error. All right, so now we're going to move on to the elimination method. Okay, so just to set this up, folks, remember back in elementary school where I said something like 11 subtract 5, and you'd have to go take a line here and go 11 and subtract 5, and you'd line them up like this, and then you'd learn how to do this way, and you'd end up getting 6. You're going to do something like that, a little bit harder though. Okay, so elimination is where we're going to line things up, and then we're going to add or subtract to eliminate. All right, up to this point we have solved for x and y by either graphing or substitution. Graphing can be found to be very time consuming or inaccurate if your point of intersection is outside your graph or in the crosshairs. Substitution can get nasty fractions. This leads us to the introduction of solving by elimination, which is method number 3, but it's method number 2, or it's your second way of solving algebraically. Two things to remember, and this is back to when you solved linear equations. Multiplying both sides of an equation by a constant does not change the solution. Just think of doubling a recipe of cookies. The final product is still the same cookie, there's just more of it. Okay, and number 2, adding or subtracting equations of a linear system does not change the solution. So you're going to see when we do these steps for elimination that most are the same, but a couple are different. Okay, but let's take a look at the key first. The key for the elimination method is to add or subtract the equations in order to eliminate one of the variables. Last day we substituted to remove a variable. Today we're going to add or subtract to eliminate. Okay, so you'll notice you're going to label equations 1, 2. That's been the same all along. Okay, you're going to multiply one or both equations to have the same number, not the sign, in front of either the x or the y variables. You're either going to add or subtract to eliminate, and sub in the known or unknown value. Sub in the known value to solve the unknown value, and these are all the same as before. Okay. All right. Let's take a look, ladies and gentlemen, at our first example. Okay. So example 1, solve the linear system and to check it. Okay. So the first thing we can do is label equations 1 and 2. Okay. Notice, ladies and gentlemen, they're lined up. The x's are lined up, the y's are lined up, and the constants are lined up. So if I draw a line there, we could do some elimination or subtraction. Elimination by addition or subtraction. The question I want to ask is, how do we get rid of one variable, either x or y, by adding, subtracting, or multiplying by a constant? Well, in this case, we notice if we look at the x's, we've got negative 3x for one equation and positive 3x for the other. Would you add or subtract that in order to eliminate the x's? You would add it, right? So let's just make a general rule here. And I'm going to put it in a bubble because it's the important thing to remember. Okay, you're going to add when the signs in front of the constant or the variable we're looking at. So add when signs are opposite. But we're going to subtract when signs are the same. Okay. So I'm just going to give myself a little bit more room here. I apologize for a sec. Let me just give myself a little bit more room here because we do need to check the solution as well. Okay. So the first thing I'm going to do is I'm just going to rewrite this system here so I can manipulate it below. So just rewrite it. Okay. So we talked, ladies and gentlemen, about getting the numbers, not the sign, in front of either x or y the same. So I'm looking right now at my x's. Okay, so I'm going to circle them because those are what I'm going to focus on to eliminate. Notice one is positive and one is negative. In order to get rid of these, we're going to add. So I want you to actually write the word add down. Okay? Don't just put a plus sign. Okay, so by adding, that's telling me I'm going to add them, and whatever I do to one term, I have to do the same to the other. So negative 3x plus 3x is 0x. I don't write anything down. I do the same for the rest of the system. So 4y plus 1y is 5y equals my second, I apologize, I forgot to label my second equation there. And now we do the same adding all the constants. So my fault, 7 plus negative 2 is going to be 5. Notice we have one variable and it's easy to solve, so we divide both sides by 5, so y equals 1. Okay, once we do that, we sub, same as once we've got our one variable solved, the exact same process that we did for substitution is exactly the same. So we're going to sub y equals 1 into, which one's easiest, guys? I think into 2. So it's going to be 3x plus 1 equals negative 2. 3x equals negative 2 minus 1. 3x equals negative 3. Divide both sides by 3. So x equals negative 1. So let's put our therefore statement down. Therefore, solution xy equals, make sure you go in order, x first, so negative 1 and 1. Now it also says to check it, guys. So we're going to check this in both first and second equation. So tell me you're going to check. Okay, so you set up a left side, right side chart for both the first equation and for the second equation. Okay, so for the first equation, we've got equals negative 3x plus 4y for the left side and equals 7 for the right side. Sub in our values, so it's going to be negative 3 times negative 1 plus 4 times 1. Watch your integer laws here, folks. So you're going to have 3 plus 4 equals 7. So far, the first one works. Let's go for the second one. The left side is 3x plus y, and the right side equals negative 2. Sub in our values. So it's going to be 3 times negative 1 plus 1. That's going to equal negative 3 plus 1, which equals negative 2. So does left side and right side equal for both? Yes. So don't forget to communicate that, since left side equals right side for both. Therefore, solution negative 1 and 1 is correct. Awesome. Okay, example 2. We're going to go a little, well, you don't have to check it this time. We're just going to solve for this one. Okay, so we got equation 1 and we got equation 2. If we look at our x's, the numbers in front of x are 3 and 5. They're not the same. If we look at y's, we've got a 2 y, one that's positive and one that's negative. So we don't worry about the sign, but as long as the numerical value is the same. So let's focus on that. So let's focus to eliminate these because they're the same. Okay, looking at, same in terms of the number, not in terms of their sign. Okay, so let's take a look. If one is positive and one is negative and we want to eliminate them, are we going to add or subtract them? In this case, we need to add. So write down add, and whatever we do to one thing in our equation, we do to one term in our equation, we do the same to all. So we're going to add 3x plus 5x is 8x. Negative 2y plus 2y is going to be 0y, so that cancels. And then we're going to take 6 plus 10, which is 16. Divide both sides by 8. X equals 2. Pretty easy, eh, guys? People like the elimination method the best, as long as they can set it up nicely like this. Okay? So now we do the second part. Sub x equals 2 into whatever equation you choose. I'm going to choose the first one because it looks like smaller numbers. So 3 times 2 minus 2y equals 6. 6 minus 2y equals 6. Oh, negative 2y equals 6 minus 6. If you take 6 and subtract 6, you're left with 0. Okay, and then to get y by itself, divide both sides by negative 2. And y equals 0. So therefore, solution xy equals 2 and 0 in an ordered pair in brackets. All right. All right, let's try this next one. See if we can figure this one out. It's a little harder. And I got one more after this, so hang in there with me. So looking at this, I've got equation 1 and I've got equation 2. Looking at the x's, are they the same number, not sign? No. Looking at the y's, are they the same number? No. So we're going to have to do something with that next step that it said, step 2 in our list of steps. Multiply one or both equations to have the same number. So let's multiply. If you haven't thought about this, how do we get the second equation to look similar to the first? You're going to take the second equation and you're going to times it by 2. So I want you to line it up like that. So it's going to be 2x minus 2y equals 2. Make sure that you multiply them all by 2. And our communication now is going to look like 2, equation 2, but times by 2. And the first one doesn't need to be multiplied, so you just rewrite it so that it can be over top of it. And just label that equation 1. Okay, so now, ladies and gentlemen, I've got my x's the same, so I'm going to focus on eliminating those. And since the signs are the same, what am I going to do this time? I'm actually going to subtract. Make sure you write the entire word down, not a negative sign, because people might interpret that. For example, say you go to subtract this and you got a negative out here, and you go something like 8y, then you're going to think it's negative 8y, but it's not. Okay, so always write the word down. So we're going to subtract. So 2x subtract 2x is 0x's, so we don't include it. Then we got 5y subtract negative 2y. So when you subtract a negative, it becomes a positive. So we're going to have 7y equals 16 subtract 2 is 14. We're going to divide both sides by 7. So y equals 2. I didn't mean to put a solid line across there. I'm just going to fix that. Okay, so we know y equals 2. You might say, hey, Miss R, I'm over on the wrong side of the right side of the paper, but you can just take your arrow and bring it back over. That's okay. So I'm going to say sub. I'm just doing that to save space, folks, because you won't need to waste paper. So sub y equals 2 into equation 2 is easiest. Go back to the original. There's going to be x minus 2 equals 1. X equals 1 plus 2. So x equals 3. Okay? So therefore, solution xy equals 3 and 2. Hopefully you're getting the hang of that, folks, and see the patterning. I've got one more example for you. This is as hard as it gets, ladies and gentlemen. Example 4. Solve for x and y. That means another way of solving for the solution. Okay? Now, we could label 1 and 2. Okay? We look at our x's, and we've got a 2x and a 3x. If we wanted to get the x's the same, we'd have to do some multiplication, and we'd end up with 3 times 2, which would be 6x, right? That's the biggest number that both those could go into. Or we can do with the y's. We've got a 4 and a 3, which is 12. So let's focus on the x's. Okay? If we want to end up with 6x, we've got to figure out what we're going to multiply, or negative 6, that doesn't matter, just the 6x for the number. Okay, so currently we have 2x. What do we have to multiply it by to get 3x? We've got to multiply it by 3. So we're going to take the entire first equation and multiply it by 3. So that's going to be 6x plus 12y equals 21. And my communication is going to be 1 times 3. Take a look at the second equation. To get 6x, we already have 3x, so you're going to times it by 2. Whatever you do to one term, you do the same to all the terms in the equation. So we're going to multiply equation 2 entirely by 2. So it's going to be 6x minus 6y equals 4, and that's equation 2 times 2. Now we draw our line, and we notice, hey, our x's are now the same, so we had to figure out, do we add or subtract this system? And in this case, we subtract. Okay, so be careful here. 12y subtract negative 6y. Subtracting a negative is positive. So you're going to have 18y equals 21 subtract 4 is 17. To get y by itself, apologize, you got to divide both sides by 18. And you're going to leave it as a fraction. So y equals 17 over 18. And that's not fun, but guess what? Fractions are part of real life. So we're going to take that, and we're going to sub it into, which equation do you want to sub it into? Probably the second one. So we're going to sub y. Do you want to do some math with us, Deetsy? Or Greg? No? Okay, Greg doesn't want to do any work. Oh, there we go. Words to live by. Okay, so we're going to sub y equals 17/18 into equation 2. And we've got 3x minus 3 times that fraction, which is 17 over 18, equals 2. Look to see if you can simplify here, folks. For example, 3 goes into 18 6 times. It goes into negative 3, negative 1 times. Okay, to help you with that. So what are we left with? 3x minus 17 over 6 equals 2. You could plug that in your calculator and figure it out, or just bring it to the other side first, and then we can decide what to do with it. Okay. So if you don't have one of those fancy calculators that has the fraction button on it, you just need to get a lowest common denominator of 6. So 12 over 6 is the same as 2. Okay, because 6 goes into 12 twice. I'm just putting a lowest common denominator so I can add them. Okay, so 3x equals 29 over 6. And this might be the confusing part. Now, how do I get x by itself? You can realize that it's 3x over 1, and you can cross multiply this. So you would have 18x equals 29, and divide both sides by 18. I know you're saying, Miss R, this is a crazy fraction, and it is. X equals 29 over 18. So therefore, solution xy equals 29/18 over 17/18. And wow, that was a crazy example. I know. Anyway, we are done our lesson, folks. Give these examples a try on page 142, 2 ACE, 3 ACE, 4 ACG, 5 ACE, 6 ACG, 8 ACG, and 9 ACG. Have a fabulous day, and hopefully you enjoy the elimination method.